All right. So for this activity, we were launching the ball off the end of the table, and let's use some data from one of you guys so that we can see what our answers should be. So the things you should have measured. You measured a height of the table. That will give us delta y. So let's see. Brandon, what did you guys get?
0.774 meters.
Okay, so that means your delta y was negative 0.774 meters. Why do we put a negative sign in there? Because its change in position was negative. It started up here and ended up down there, down negative. Okay, now so table 3, what about your delta x? What was your average range that you got? 0.44 meters? 0.45. I can go there. Boop, just like that. Okay, so I told you could not use a stopwatch. Did you notice that the motion was pretty quick? Can you imagine trying to stopwatch that? That would be really, really hard and you'd have lots of error in it. But with these bits of information, we should be able to find the initial velocity in the x direction, which is the initial velocity of our object. Remember, it's being shot straight off here, so the initial velocity is the initial velocity in the x direction. Does anybody know what the initial velocity in the y direction would be for this horizontal projectile motion? 0. That's right. Okay, so delta x is equal to the initial velocity in the x direction times time. Now I've got this delta x. I want this guy right here, but this time is not given and I didn't use a stopwatch. Is there a way to find time that with some of our other measurements? What did you guys do? Did you use maybe a delta y equation? Delta y equals the initial velocity in the y direction t minus 1/2 gt squared. Does that look familiar? So our initial velocity in the y direction is 0. So that's nice. Just making my substitution here. Now, we were doing a real live lab on the real Earth. What is the best value to use for the acceleration due to gravity in this real live lab? Probably 9.81. But you guys probably use 10 because I'm trying to train you to use 10. It's fine. If you're doing a lab where we need to use the acceleration due to gravity as 9.81 so that we can reduce our error and things like that, then I will make sure I make a big deal about it and we're all reminded. But it's okay for now for us to use our estimated 10. T squared. So, table 3, what did y'all get for t when you solved it out? Did y'all solve t? That's a 9. So about 0.393 seconds. Okay, so now what can I do to find that initial velocity in the x direction? I've got this guy right here. I just solved for time. Can I find the initial velocity in the x direction? Yay! All right, so I forgot what you told me it was, 0.45 will equal our initial velocity in the x direction times 0.393. Therefore, our velocity in the x direction, which is the initial velocity, would be 1 point, what'd y'all get? 1.137, so like that. 1.14 caterpillars meters per second. Okay, yay! Now I'm not saying that they had the best data or anything, I just picked someone data to work with. Okay, so now I have the initial velocity. Now my next question is, my challenge question here, what is the final speed and direction or resultant velocity, speed and direction means resultant velocity, of the marble? So right before it hits the ground. I know that it stopped moving eventually. That's not what we're looking for. Okay, that the floor was interacting with the object. So what is the final velocity from the interaction with just the acceleration due to gravity before it hits the floor? So work with your friends and see if you can figure out what the final speed and direction is. All right, so if I'm looking for the final speed and direction, when the object hits the floor, okay, so here was our marble, and it was like boop, 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 like that. And there was the height. Actually, I'm going to make it a nice solid line. There's the height of the table and the floor. Notice that this is a parabola. It's not a hypotenuse of that triangle. Okay? So it was moving horizontally to begin with, and the velocity was changing direction all the time, which means that it was accelerating, right? Change in velocity means acceleration. And when it hits the ground, it's moving in this resultant direction. So if I blow up this vector, pretend like I can draw vectors really pretty. So when it hits the ground, I like to use a little r to tell me that it's the resultant, that it's the x and the y together. So when it hits the ground, it's moving to the right in the x direction. Actually didn't do a very good job of putting that where I could write the r. And it is moving down in the y direction. Tell me about the velocity in the x direction the whole time. It is the same because we're under the influence of the acceleration or the force of gravity only. So this is our 1.14 meters per second. Now I need to find the final velocity in the y direction. There's a couple of ways I can solve that right now, but I think the easiest way to do it is use Vy equals V naught y minus gt. What is the initial velocity in the y direction for this horizontal launch? 0. Minus, we're still using our approximation of 10. You guys got a time of 0.393. So the velocity in the y direction when it hits the ground, ooh, it's negative. Is that okay?
Yes.
Why is the negative sign okay? Because it's going down. That's the direction. Velocity is magnitude and direction. So then V resultant would be the square root of Vx squared plus Vy squared. Does this look familiar? Sorry, I'm writing faster than my pen can handle it. I'm like a ninja. Just kidding. I tell myself that though so I can, daily affirmations. I'm a ninja. I'm a ninja. I can do this. Why am I dropping the negative sign here? I'm going to square it anyway, and you guys, I love you, but you will make a goofy mistake with your calculator and not square the negative sign, so you'll wind up taking 1.14 squared minus 3.93 squared and just get wacky answers. You'd wind up with an imaginary number or something like that. So did you guys get like 4.04 meters per second? 4.09? What did you get? I'm going to use yours because I want to. I'm just done. All right, now what about the angle? That's the magnitude. What about the direction part? Can you just say below the horizontal? Not enough information. We need to know exactly how far below the horizontal. So the inverse tan? What was our y component? I always do the absolute value so that I get a value for the angle, and then I look at the picture and pick, is it above the horizontal or below the horizontal? Is that about 75 degrees? 74? 74 point what? Help me out. No? What'd you get, Brandon? 74. We'll go 74. How about that? Good enough. So now we have the final resultant velocity, 4.07 meters per second at 74 degrees below the horizontal. Why is it below the horizontal? Oops. Somebody's so excited they're playing some music. You don't understand the below the part? No? Or you don't understand your phone? So notice that when it hits the ground, is the arrow, is our vector in the X direction? Or is it in the Y direction? Is it above the horizontal or is it below the horizontal? It's below, so that's where we get the below part, below the horizontal.